Well, question number 6 says a particle moves in a straight line. It starts from rest at time t equal to 0 and accelerates at 0.6 t meter per second square for 4 seconds, reaching a speed of v meter per second. The particle then travels at v meter per second for 11 seconds and finally slows down with constant deceleration, stopping after a further 5 seconds. Show that v is equal to 4.8. Okay, we have to find the final velocity, and whenever such question arises, then we think of the concept of Shubert formula, that is simply v is equal to u plus at. But in this case we cannot apply that simple formula, because look at this, v equal to u plus at is applicable for constant acceleration. Here it is written that the acceleration is 0.6 t meter per second square. That means it's not constant. Acceleration is not constant. So what we can do is we will have to integrate this acceleration. So a is equal to what? 0.6 t. If we integrate acceleration, we get in term of t. If we integrate acceleration, we get velocity. So it is going to be point six over 2, then t square plus c. Since the particle starts from origin, look at this, it starts from rest. That means t, when t is equal to 0, velocity was also 0. That means there is no constant value. Hence our v, if we integrate acceleration, it is our velocity. Integrand of acceleration is velocity, or v is equal to 0.3 t squared. Okay, now they have told us to find the value of v. So 0.3, and for the first phase our time is, look at this, the span of time is 4 seconds. So it is 4 square. So 16 into 0.3 is 4.8. Then they have told us to show this. We have shown. Okay. Then the next part says sketch a velocity time graph for the motion. Okay. So there are three parts. Look at this. In the first case, there was a an acceleration which is not uniform. Then there is the particle travels at v meter per second, constant speed, constant velocity, no acceleration. Then finally deceleration. So there are three parts. Let us draw the graph. Yes, over here let us extend this. We can write here horizontal axis is t meter per second. Okay, and it is vt. This is 0. From 0 particle started moving onward, and vertical axis is v meter per second. V meter per second. After that it is 1. Okay, v meter per second. No, let me write this way, meter per second. Well, so for the in the first case it was for 4 seconds. Let us write 4. Then more 11 seconds, that means it will be 15, and finally 5 more seconds we may write here 20. Okay. So for first 4 seconds there was uh, here, suppose this is V. This is V meter per second. Okay. Then not there, let us write over here, let it be V. So the particle was accelerating at this rate, then until it is 15 seconds, that means for 11 seconds it was at a constant speed. After that, in the next 5 seconds it turns to 0, that means it comes down. So let us see whether we are on the right track or not. Yes, it says that first accelerates 0.60 meter per second square for 4 seconds. Yes, it is 4. Then reaching a speed of v meter, the particle then travels at v meter per second for 11 seconds. So 4 plus 11 means 15. After that, finally slows down with constant deceleration. Yes, this is constant deceleration. So we can write the coordinates over there. No, coordinates can be written in the next one. Well, so let's move on to question number C. C says, find an expression in terms of t for the velocity of the particle for 15 until 20 seconds. Okay, so if we draw the figure over here, it will look for the last phase. Last phase is a triangle. If we go back to the previous page, look at this. Last phase from 15 to 20, it is a triangle, right angle triangle. So let us draw the right angle triangle. Yes, it will look like this somewhat. Here the coordinates were 15 0, 15 0. Okay, and here it was 20 0, 20, and time, I mean time was 20 second and velocity was 0. Well, then it was v. Okay, so v was 4.8, sorry, the x coordinate, I mean horizontal coordinate was 15 and y coordinate was v, means 4.8. Now we will find the expression for velocity. Okay, and let us find first a gradient. Okay, so gradient is equal to gradient for the equation of this acceleration or deceleration. We'll have to find the gradient first. So gradient is equal to, let's choose the final velocity first. So it is 0 minus 0 minus 4.8 over 20 minus 15. Okay, 20 minus 15 equal to, what is it going to be, 5 over sorry, negative 4.8 over 5, means it is going to be, if we divide 48 by 5, it is going to be 9.6. So 0.96 minus 0.96 is our gradient. Then we can form an equation in terms of vt. Okay, so v minus, they have told the equation to expression. Expression is, we'll just form the equation. V is our y coordinate, so let's choose this coordinate. Okay, so v minus 20, sorry, v minus 20 is equal to our gradient was negative 0.96 into x minus, what was the x coordinate? X minus 20. X was actually t minus 20. T minus 20. So finally our v is going to be v is equal to, hence v is equal to 0.96 t, negative 0.96 t, then plus 20 into 0.96, it's 19.2. So 19.2 and plus 20, so it is going to be it is plus 19.2. And I think here we made a mistake. It should not be, the vertical coordinate was not 20, it was 0 actually. It was 0. So this is what the expression of velocity, we may leave this as answer. Well, the final question says this is find the total distance traveled by the particle, and if we look at the graph, there are three segments in the graph. Look at this three segment. First segment is from 0 until 4. Okay. Second segment is 4 until 15. Okay. For this one. First segment is this one. 0 until 4 second. And second segment is 4 until 15 seconds. Then third is 15 into 20. So among these three segments, look, first part is from 0 to 4. This is not uniform. So we will have to accelerate the velocity. Let us see what was our velocity expression. The velocity was this. Look at this. The expression for velocity for the first phase was v equal to 0.3 t squared. So let us write one after the other. For 0 until, for 0 until 4 seconds. 4 seconds. Our v was what? 0.3 t square. Okay. Then if we integrate our velocity in terms of t, it is v dt equal to, it is going to be zero point 0.3. If we increase by 1, it is going to be 3, and t cube, and plus c constant. Actually constant value will be 0 because the particle started from rest. When t was 0, displacement was also 0. Hence our s1 is equal to what? If we can avoid the other part also. Look at this. If we convert it into definite integration, then it is going to be from 0 until 4. Okay, 0 until 4. So here our limit is 0 until 4. 0 until 4. It is going to, if we divide 0.3 by 3, it is going to be 0.1 into t cube means 4 cube. 4 cube means actually 64, isn't it? 64, and 0 means 0. So it is going to be actually 6.4 meter for the first phase. Okay. Now the second phase is, if we consider this one, the second phase means starting from here until here. This is actually a trapezoidal region. So for trapezoidal region, here two parallel lines is from 4 to 20 means 16, and from 4 to 15 it's 11. So 11 plus 16. Let us write for the second phase. For I think I should change the ink. it is, let it be taken this, for 4 until, 4 until how much, 20, the last, until the last moment. S2, displacement S2 is equal to, that is area of the trapezium, half of, we have already calculated the sum of the parallel lines is 16 plus 11, plus 11, and vertical height is nothing but v is equal to, it was 4.8, it is not 4, it was 4.8, 4.8, let it be written as 4.8. So height is 4.8. Let us write into 4.8 into 4.8. Then if we multiply, it is 27, 27 into 4.8, 27 into 4.8, not 4.8. If we divide 4.8 by 2, it is going to be 2.4, 2.4. Let us multiply this 27 into 2.4, 27 into 2.4, 27 into 64.8, 64.8 meters. Now total distance is to be obtained. Just let us find the sum of these two distance. So total distance is equal to, total distance, total distance is equal to, first phase was for 6.4, so 6.4 plus, in the second phase the distance traveled by the particle was 64.8, 64.8 meter, equal to, if we add up 64 plus 6, 70, 70 plus 1.2, so 71.2 meter, 71.2 meter is the total distance traveled by the particle since the beginning till it comes to rest again. So that's all about the solution. It's actually not difficult or complicated at all. So thank you all for being with me. Allah Hafiz.